Good afternoon, everyone. We must thank Economic Times Energy World for coming out with a very apt discussion on how you unlock higher solar farm returns, especially in these falling tariff regimes. This is probably the discussion topic around the world and so also in India. So I welcome all the panelists and all the viewers to this session. Just to put the context, Indian renewable energy sector is poised for a growth, and not only growth, it is going to grow leaps and bounds. The need of the hour probably would be how we use technology, innovations to constantly bring down the costs of energy, especially the levelized cost of energy, and how we improve the throughput efficiency of our solar plants. And when I say throughput efficiency, it is how we manage all our resources, whether it is infrastructure of evacuation, whether it is land, so on and so forth, to improve the overall cost of the plant so that we are there for delivering the low cost energy and making the solar projects shine under the sun. They've been doing exceptionally well, but we still have a long way to go. India has a very ambitious target of 450 gigawatt by 2030, and I believe almost 75% of that will be met by solar. So innovation and technology would be a key driver to improving the efficiencies as well as bringing down the costs. I have with me panelists who are probably experts in their own right, and they have been probably the leaders who have shaped some of the things in the industry. I would like now to introduce you to this august panel, and then we will discuss the pros and cons of how and what we can do about the higher solar farm returns. So let me introduce to you Sanjeev Aggarwal, who is the founder, MD and CEO of Amplus Solar. Sanjeev has probably over two and a half decades of experience in infrastructure and power sector. And he has probably also led the revolution of rooftop in India. Amplus Solar is known for their rooftop projects in India, as well as in their open CNI segments. So welcome Sanjeev on board. Let me introduce the next panelist is Mr. Koo Jun, who is the Senior Director of Sales and Marketing of Trina Solar. You know, he has been with Trina for almost now over a decade, and he has been responsible for developing markets both in Australia and India. Trina has grown in business both in Asia Pacific tremendously under his leadership, and he has shown the way how solar markets can be developed. So while he may be representing the manufacturing industry, but the fact is we do walk hand in hand to develop the solar markets. Welcome, Koo, to this session. I have with me next Mr. Goutam Samanta. He's a technologist and he heads the PV technology in Juniper Green Energy. With almost 3.5 decades of experience in electronics industries, including 27 years in international PV industries, he probably is the man of the panel today who would guide us on what technologies and how they have shaped the solar industry. He was the founder member of Mozambique, also was the auditor of EDF in Southeast Asia, and so he is probably one of the most experienced in the Solar Technology Forum on this panel. Welcome, Mr. Goutam. I have next with me Parag Sharma, the founder and CEO of O2 Power. Parag has over 2.5 decades of experience, both in terms of renewables, development, and in infrastructure execution. Parag has worked with KPMG, ABB, and till a year back, if I'm not wrong, maybe even 8, 9 months back, Parag was one of the key members of a very leading renewable IPP, and he has shaped the growth of that IPP independently. He's a, I would say, a sports or a fitness fanatic. He's a marathon runner, and I welcome Parag on this panel. I think so. These are the panelists, what we have. I've not missed out anybody. Now, I would like to go to each of the panelists. No, sorry, I think so. I missed out Mr. Rengarajan. I was wondering where I missed out. Mr. Rengarajan, formerly called Renga, he's the Chief Operating Officer of Brookfield Renewable India. He's over around 7 years of experience in renewables and a decade long in the process industries, both in oil and gas. He has led various functions like business development, engineering and technology, supply chain, projects, and operative. He's worked with ABB, Sun Edison, SoftBank Energy, and now Brookfield. Brookfield is in India now, who are developing solar assets and developing a huge platform in India. Welcome to all my fellow panelists, and this August panel will now debate on how we are going to unlock value through technology innovation. So I would first like to go to Sanjeev. Sanjeev, what are the various impacts of high power, high bigger wafer panels on project cost for rooftop solar projects? Because the higher efficiency panels probably will give much more impact on rooftops, considering India's demographics and smaller roofs, especially in the residential sector.
Yeah, good afternoon, everyone. Thank you, Sunilji, for the good introduction to the topic and to me as well. So I think your question is very relevant because when we talk about the rooftops, particularly one of the issues that we face is about the availability of land. While we are working on the ground mounted projects, the land normally is not considered to be like a very large constraint. Though it is a we always need land for other purposes, but there's always some people can argue that okay, land is available, so why should we even consider higher wattage module? But in case of rooftop, we are always short of space, because what we really want is that on the roofs, how much wattage we can really fit. And with the coming in of the higher wattage modules, I remember till like last year back we used to have 350, 370, and suddenly now we are in a range of 450 to 550, which is like a significant shift in terms of how we can accommodate almost 30% more wattage on the same roof. So which is a good thing if we really look at if you want to generate more electricity from there. uh, and definitely it also leads to some sort of reduction in the balance of system cost. But I think the challenges that we are facing, particularly in the rooftop side with the higher wattage panels, is that suddenly these panels have come into the market, and there are a couple of things like the compatibility with some of the existing inverters. So there we are finding some challenges. So this is going to be probably resolved over a period of time. We are also finding some challenging with the clamping industry, because clamping industry has been used to handling probably the panels of a certain size. Now suddenly we are seeing larger panels. So whether the clamps are able to handle that part or not. Then we also are a little bit struggling from the manufacturer side, because as I'm told by our technical team that we have two typical technologies, M10 and M12 or G12, and both of these follow different types of little bit different technology when we want to make them compatible to the other system component. And it's important that we find out some way of combining these two ways of technology of M10 and G10, M12. So this is like prima facie, I think it's a good development, because it helps, because there's not much we can do in terms of reducing the cost now. So the cost reduction is coming more from increasing the panel sizes. So we are hopeful, and our customers also like that there are higher wattage panels available.
So one more point I want to ask you is, are there any logistic challenges involved in using these high power panels for rooftop especially?
Yeah. I think that's a very good point. In fact, I want to talk about that in terms of handling of the panels, about when we are installing them on the rooftops. So the logistical challenges are there in terms of taking these on the roof and handling them when we are installing them. So, but I guess that can be taken care of by a little bit more training to the contractors.
Okay. Thank you, Sanjeev. Let me come to Parag, who is now leading O2 Power and growing very fast. And he has the relevant experience of an IPP and doing large solar farms. Parag, do you consider that the future is ready high power modules to impact project cost significantly and thus become a criteria to attract better financing?
Thanks, Mr. Jain. So my answer to this point is that we have to be very clear about higher wattage versus higher efficiency. Many times we are talking about wattage moving to 450 watt, and not even 450. People are talking about 530, 600 watts. But it necessarily need not be an efficiency improvement. And when it is not an efficiency improvement, then there are very limited advantages as far as project cost is concerned. We are not saving on land. Only thing that we might slightly save on is a little bit of BOS cost, maybe bit of an O&M cost, because some components of O&M are module based. So these are the only two advantages, and they are not significant enough. I think what industry is waiting for, if my understanding is correct, it has been stated in various technical articles that mono-PERC efficiency has almost reached at its peak. So either we have to go down the path of experimenting with bifacial, or we have to talk about new technologies like heterojunction, perovskite, or all these new technologies which people have been talking about. Within the current mono-PERC technology, I think this wattage is confusing everyone. It is actually not an increase in efficiency.
Okay, so that's a very interesting topic, which I'll probably, this question, he has given me a clue to ask this question to the manufacturers. But how do you believe that, how will these module power gains play out in the long run? You know, we have ambitious target of 450 gigawatt, and as these module power outputs increase, as you rightly said, up to even 630 megawatts, how does it play out for the future?
Yeah, so as I said, mono-PERC is not the end of the world. Maybe bifacial slowly people will move, maybe heterojunction modules, maybe some other technologies. So in solar industry, we have always seen new innovations happening. So all those will really open the larger game, and it will lead to higher capacity, not only just wattage modules, but also more efficient modules, and that will bring down the tariff. And so as such, reaching a target of 450 gigawatt is not dependent on module wattage or efficiency, because we are already there at that tariff, which can take us to 450 gigawatt. But yes, if this efficiency improvement happens, we may become more competitive. Even with storage, we may reach to a very competitive tariff. So all those will be the additional positives if the efficiency improvement happens faster.
So this brings me to Mr. Koo. Mr. Koo, you are in the center of all this because you people are driving this innovation in terms of the size. So what are the triggers for manufacturers to push wafer size, thereby the module power upwards?
Thank you, Mr. Jain. So as manufacturers, Trina Solar, so from our point of view, the overall system, which considered by the modules and the BOS costs, and the total power generations are going to be the key element to determine the PV's LCOE, the levelized cost of energy generations. With the increase of the module powers, the quantities of numbers of module required to produce the same capacities is reduced. So as a result of that, I think the associated costs of the like installation costs, the construction costs, even the cablings are going to be used, the work they're going to be putting into it are going to be reduced as well. And in terms that you have the reducing in terms of the overall BOS costs, and that will maximizing the entire customer's so-called profits by having a lower LCOE. So by applying the larger wafer size, like what Trina is introducing right now to the industry for based on the 210 mm cell size, the module powers has dramatically increased over 100 watts over 1 year period of time. So in February of this year, in 2020, so Trina Solar has introduced a Vertex 500 watt series module, which is the ultra powers module to the world. And at the same time, over the period of 5 months, we have increased the powers on the Vertex module, and we are introducing a 600 watt module to the industry as well. And for November this month, we are going to be having a mass productions of the 540 and 550 watt module right now. And that will be rolling out to the industry. And the 600 watt module that will be in having the mass productions starting from first half of 2021. So all these higher, ultra high power module based on 210 mm wafer size that will definitely adopt the design of low power, so low voltage and high currents power, which in turn that will reduce the entire system cost. So that, from our perspective, I think that will be very key.
But would you like to answer to what Parag said, that monopack efficiency is almost as you speak, and therefore the benefits of efficiency is not seen so much?
Not true. So if you look at it right now, so from our product roadmap standpoint, a monopack's efficiency has room for improvement in terms of driving the entire module efficiency. So today we have so-called 600 watt module has already been introduced right now. And at the same time, the module power bin will continue going to be, from a roadmap standpoint, we will continue to improve the module efficiency and higher module power. That will be also key elements for driving entire system costs. On top of that, right, when you are looking at the entire so-called system costs, particularly for India's so-called the utility market context. So I think all the panelists are going to be the expert in this area. Is that besides the module power, we also looking at the avenues that bifacial module with a tracker systems, combined with the tracker systems that will provide additional yield generation, and that will also bring additional so-called cost of energy generation that will definitely improve the entire so-called efficiency for our power plants. So that's from our perspective, we believe that bifacial module with the higher efficiencies of the system costs, lower the system costs with a higher efficiency module, that would definitely bring additional value to all the so-called investors.
Okay. Now it brings me to a point, while we are improving in technology on the size, so what is going to happen is all your old modules will face the technology obsolescence problem. How will the module power gain address the challenges for modern BOS requirements during repowering? Or if the module fails and you have a string of failures, how would you fail, say after 6 years, 8 years?
If you look at this current system technology that has been used previously, that was based on 1000-watt systems, right? Today, I think we have most of the system has been so-called improved and upgraded based on 1500-watt systems. So in that sense, I think that will have improvement in terms of the BOS. you have to take care of that because these are two different systems, so-called system power at the system level. All right, coming back to answer your questions that, the lower so-called power bins and lower power systems compared to what has been introduced right now in the industry is that, for Trina, we do have so-called warranties, so-called, system compatibilities in terms of providing the older systems to continue to supply to our customers who are going to be using the older system, like 1000-volt systems today. So if you're using a 1500-volt system on the lower power system like 1000-volt, I think that system continue going to be working efficiently, all right, but not the other way around, right? So I think most of the newer systems that Trina has been introduced to the industry, like based on 1005 systems, that will stay in the industry for long. And of course, I think the systems experts they out there in the market, for all the panelists here who are going to be the so-called putting a system on the rooftop from Amplus, and people like Mr. Sharma on the largely on the developer side. I believe that these are some of the so-called system level or the platform level that I'm very sure that they will be putting all this into considerations.
Okay. Any optimum cutoff limit of the module power, especially for a region like India? There is something which you have in mind and where you will say that, okay, this is the optimum size and output of the power and it cannot go beyond that?
I guess from, as the manufacturers and as well as from the roadmap and the system application standpoint today, I think there's no limit for that. When I say there's no limit for that, in a sense, for ground mount utility scale projects, with a combination of better system efficiency, like for instance, taking the highest module power with a combinations of tracker system, that will definitely going to improve the entire system performance. All right. On the module powers perspective, today we are introducing the 600-watt module that will put into productions in the first half of 2021, and the module efficiency will continue going to improve with a much higher module power bins, and with improving of higher systems efficiency, like bifacial module with a tracker. Today we are looking at the single axis tracker to be so-called the optimum combinations of on the system improvements efficiency. So maybe in the future, when the trackers cost is coming down, and maybe the dual axis may be a so-called a better systems when the cost is coming down and provide a much better in terms of improving the entire generation. That will bring down entire system cost. For so-called cost-sensitive so-called countries, like for instance for India, as well as a very low tariff that country like India, I think improving the entire LCOE for the cost of energy generation, that will be very key. So from from our perspective, and Trina has both the module as well as the tracker system solutions offering to our customers. We believe that with the combinations of the high efficiency bifacial module with a tracker, that will probably bring a lot more sort of benefits to the developers and to customers in India.
Thank you, Mr. Ku. May I move on to Mr. Goutam? He's again a technologist. So, Mr. Goutam, in your experience, does higher module power ensure a better LCOE only in specific geographical locations, or the impact is uniform across the country?
Okay, thank you, Mr. Jain, and thank you all panelists. Okay, thank you for asking these good questions. If you look into the India, there are different generations happens because of the irradiance. So there are states like Andhra, Telangana, then Rajasthan and Gujarat, where we have a higher irradiance. Obviously, higher irradiance give a better LCOE. If you look into the LCOE equations, it is the capex means there are two things. One is that the capex which we put during the project installations, and next is the OPEX, which is another operating cost, and the other costs divided by the generations. So if you see the denominator, if you have a better generations, then we can reduce our LCOE. Now, on the first question, so if we go in the higher wattage module, as the co-panelist Paragji as well as Mr. Ku has already discussed, like the Park PRC Park modules has already reached 20.6 to 21% efficiency, or in the other words, in the layman's language, that per square meter it generates 210 watt modules. If we go back a year back in 2019, so we were getting two type of modules. These are monofacial P-type, and one is the polycrystalline, other is the monocrystalline. If we look at the polycrystalline materials in 2019, we are procuring something like the 330 watt. But also at the same time, these are full cell, but also full cell with the monocrystalline, it was a 300, 385. Now, what is the change has come in 2020 that we are getting? What I am talking about, there's a G1 wafer, 158.75 by 158.75. Now, let me talk about the monocrystalline Park cell, which was in the full 380 watt. So when you cut the wafer first, then what do you do actually? We improved the edge isolations, which improved your, the shunt resistance and also the fill factor. Now, what happens in a full cells? The same light is falling, but how much we are converting? So you are improving a little bit on the fill factor as well as in the series resistance, right? So it's not only that. If you look in terms of the bus bars, it was like the 5 bus bars, and today it is like 9 bus bars. So what has happened, in the change in the 5 bus bar, and this bus bar was a rectangular itself, 900 micron. It was the width, and the thickness was 250 microns, 0.25 millimeters, and the light falls on it and goes back. So we are losing almost like 3% of the solar radiations, which is falling on the solar cells, right? If you look in the today with the 9 bus bars, so what is that bus bar? These bus bars are made of soldered by the wires, 350 microns wire. So in the solar cells, we have to look into the 2 things. One is that how much is the coverage area? I mean, if we can reduce in the front side coverage area, that means the light falling. So something like the 7 to 8% is a ballpark figure. If we have a siding because of the grid patterns and all. So when we change over, from the 5 bus bar to the 9 bus bars, we increased, the overall solderability, the durability of the particular, the module, because of the mechanical strength. The other one is that reduce the series resistance and improving the fill factor, right? So therefore, so we increase like 1 bin class, 5 to 8 watt for the half cut. Now, 410 watt module today, if you look into this, the geometry earlier in 2019 with the monofacial cells and monocrystalline, the off square, the corner is leaving 2.5%, but today the half cut cells with the full square and rectangle cell. That means there are 2 things. The area coverage is also 2.5% more. So that means there are 2 additional advantage. One is that area that we are increasing. So earlier area is like at least 3%, 2.5%, 3% less, and today it is 2% more. So therefore, we are increasing at least 20 to 25 watt more. Apart from that, from a developer's perspective, we have to look into the other parameters, the performance. So from the Indian context, when we go for installations on the higher radius area, is not only that the temperature. One is that the ambient temperature, other one is the cell temperature. So the cell temperature is always 25 degrees higher than the module temperature or the ambient temperature. Now, what happens to the solar cells? If you look into the parameters of the solar cell, technically, there is a parameter called temperature coefficient. If you look into the poly, the temperature coefficient of 0.41, and in case of a mono, 0.35, now it has come. So the incremental benefit, this is this temperature coefficient is partial, per module. So we have a, something like, 72 cells earlier, now is 144. Now the 144 is equivalent, is parallel, so almost equivalent, acting as a 72 cells. So therefore, from a developer's perspective, one is that temperature coefficient. The other things also we have to look at things. The first year degradations and also subsequent, because the module performance is what we calculate is for 25 years, right? So if you look into the poly, it was given like 2.5% on the first year, and second year to 25th year, it was 0.71 for poly module monofacial, But when we switched over in 2019 itself, if we look at the monocrystalline materials, the temperature coefficient has, the performance, the performance, the year degradations is 2.5%, but subsequent year, 0.65 and all. But today we are getting much better, 0.55 and all. So this is about the monofacial with the conventional backseat module, right? If you look into the new innovations which is coming into the things, the glass module as well as the bifacial. But if you look at the glass module, the first year degradations is 2% and subsequent year is 0.4%. But for developers, we signed a PPA for 25 years, So when the polycrystalline materials, after 25 years, the power on the modules was 80%. It is not only that, there is a huge degradation on that, In the monocrystalline materials in 2019, or in the conventional backseat that we are getting is 0.85% the power, but with the glass modules is 87% power. So from the generation perspective, if you look into the same equations on the LCOE, from the developer perspective, this is one of the biggest advantage coming back to the high power modules, As we switching over, in a sense, in 2020, and a lot of the products has already developed into place, which is 182 by 182 millimeter, and then it's going to 210 by 210 millimeters. So if we look into the 182, from the present context, is only 31% of the area it improves. So therefore, the 410 watt modules, will be somewhere is a 500 plus, 520. But if you look into the area like 210 by 210, so from the baseline, like 158.75 to 158.75, it is increasing 75% overall area, So it is only improving the area. But from the developer's perspective, we have to be, we are very satisfied in a sense, like, for the compared to the full cell, when we make a card cell, mechanically it improves, the mechanical strength, and also because of the multi-busbar designs, So if you look at the ultimate O&M, particularly on the operations, if there is a mishandling or any other things, there is a microcax, whether it will be separated or this will be a danger for a developer, I say it is no. So this is on a much better place. Thank you, Jain sir.
Okay, thank you so much for giving us this in-depth view. Just one more question from you is that, will the use of robotics in the O&M function, will the bigger modules help, or there are any challenges involved in that?
As far as now everybody has switching over to the robotic system for the dry cleaning. Yes, dry cleaning, I believe this is the best options. Earlier we used to do the wet cleaning, and as you know, the wet cleaning is something like every year we waste I think 5,000 to 7,000 liter per megawatt, something like that. So we are saving that. So in the robotic cleaning for a larger module size, absolutely there is no issue. So why it is that? See, the robot cleaning, if you see in the module, the robots run into the rail. So therefore, it doesn't touch the, or doesn't make any kind of the mechanical impact on the surface of the modules. Or in other words, what I want to say, if we compare with the earlier, the conventional, the wet cleaning, compared with the dry cleaning, in wet cleaning, what happens? There are two different factors. One is that how we cleaning, and also the TDS in the water, So that was creating a kind of a problem in the particularly in our modules, But this wet cleaning, either in a smaller size of the device, absolutely there is no problem. And it can cover, from 15 meter to, I think, 200 meters, per square meters. The robot is fast, It depending on the which kind of robots, it's a size like 2 meter, 4 meter, or 6 meter, and the weight is not much. So, for example, the 4-meter robot is something like, it's 42 kilo, yeah, and also it doesn't touch. There is a different kind of the fiber and the membranes, which is cleaning the module surface, and the module surface has got this silicon dioxide and silicon nitride, the anti-reflection coating, and this is a very, very hard coating. This doesn't get any kind of damage, and all the module suppliers has given a back-to-back warranty that there is no change in the warranty patterns, until unless you damage the module because of the cleaning and other things. Absolutely.
Thank you, Mr. Goutam. So let me now come to Renga, if I may call him so. So Renga, you are with Brookfield, and Brookfield is more of a aggregator of solar or wind or renewable assets. At least that's what you can correct me if I'm wrong. And therefore you would be acquiring assets which have been already operating, and they would be using different technologies because they would have been set up over a period of time. As an aggregator and then an operations of those assets, do you find challenges with the new modules coming in and the new technology coming in? And how do you brace for that in your operating solar farms?
Thank you, Mr. Jain. So just to add, Brookfield Renewables, they are globally present. And in addition to solar wind, we also do a lot of hydro, mostly in the US and in the Latin American area. We also have a few pumped hydro storages in those areas. So in India, we typically focus on solar and wind. And as you rightly said, we kind of aggregate and own the plant, and many of the times we hold the projects to maturity. So typically when we do that, the good side is that more and more advancements in technology keeps coming in. It's good to have that. But when you start aggregating, as you said, we will have projects which are built in multiple stages of time. So we even have projects which are with thin film series 2 modules and all. Now, when we have some issues with that modules because of wear and tear, when we go ahead and have to replace that, we have to have a lot of design considerations to be taken. And as in one of the other panelists was saying, at times it's easier to find a replacement straight away. At times we may have to replace the whole subsystem or a part of the system. So it's at sometimes challenging, like things move from 1,000-volt system to 1,500-volt system. Getting an inverter at 1,000-volt system for now, it's easier. But when I say it's the next 5 years down the line, we don't know how exactly that's going to impact us. We kind of manage that through the long-term warranty services which are provided by the suppliers. But it's quite a challenge to manage that. As of now, we keep enough spares and the warranties with the manufacturers. But they also would have difficulties going forward because the whole ecosystem would have been built for the newer products which is coming in. So it's going to be a kind of catch-up activity. We just keep some budgets and funds specifically for those.
So many of your projects which you have acquired would be with the old dated water cleaning system and not dry cleaning system.
Right.
As an operation of assets under your control, do you see that you would be using more and more technology, and how does it impact when the higher, bigger modules come in?
Typically, even with the older projects where there are frameless thin film modules, it's pretty difficult with the existing robotic solutions what we have. What we mostly have now is for the frame, the modules with frame. They can be cleaned pretty easily with the number of robotic solutions available in the market. So for all the thin film modules, we're still searching for solutions, how to optimize the usage of water as well, even the environment and the water difficulties in these areas. But for the crystalline modules, we absolutely don't have any problem. There are enough and more solutions, and we're slowly deploying and moving away from using water and moving into this. Of course, we generally do a pilot, look for 3 to 4 months of performance. We also take help of good consultants who can say if there is any damage to the panel and all those. So after we run a successful pilot, we then start deploying those. The more and more bigger panels keep coming in. I think the other products as well will keep the pace along with that development, and that's the expectation that we'll be able to think. So we also keep a pace track on the pace, how things are improving, and industry leaders like you will always show the way to us how the new projects are being developed, and that's one of the cues we take and develop our projects.
Okay, moving away from this technology part, RE Invest in India is around the corner, and you are a part of a very big global setup of, it's a large Canadian money. Do you think that with the vision of 450 gigawatts in play, is it time for new reforms in the renewable sector to attract new investments?
I think certainly. So I think having said that, certainly, even this decade, right, when we take from 2010 to 2020, where we are now, I think we've seen a considerable amount of improvements, and thanks to the government, the nodal agencies, industry leaders like you, Parag, we've seen consistent messaging from the industry leaders with the nodal agencies like SECI and TBC and all. They've been always supportive, and even with the ministries. And where we are now, I would say our PPAs, the PSAs which are being signed for each of the projects, they're all at least in par with many of the international markets as well. All right, so any global investors would typically appreciate that, and there's a huge and a good amount of job which has been done already. But having said that, the electricity being a concurrent subject in India, right? Both state and the central has the authority over it. At times we get into difficulties when issues have to be solved. So with regards to that, there has already been representations. Government also has taken steps to put across, taking input from all the stakeholders, and trying to make the changes to Electricity Act, the tariff policy, bidding guidelines, almost every policy and guideline which could be touched upon. I think all of us have put our efforts and shared it as well. But at times what happens is it's difficult for the government also to take action just because it interests one part of the ecosystem, right? The discoms are there, the states are there. So when they really take it to them, they face a lot of difficulties to just go and pass it on. So maybe it would be a good idea that we kind of get together along with the ecosystem, find a way or to meet maybe more frequently, and then have a focused approach on doing these improvements, and also to touch these more frequently, not like once in 20 years or 10 years, like Electricity Act is refined much earlier. And the way the dynamics are happening, it'll be too late to touch every 10 years, 20 years. Maybe a 5-year, maybe a 4-year thing. If it's going to be touched again and again, then there will be a good amount of openness among the ecosystem, right, to accept few things and then try it out for next 3-4 years and then revive it, right? So it's never late, but it's a good time to really start that. Otherwise, it's going to be tough to really achieve the 450 as well. So we know even the 175. We're all pushing towards it, but there are challenges, right? So at least that could be overcome when we think of 2030.
Thank you, Ranga. May I come to Parag? Parag, with the panel sizes increasing, and India as a country has been used to transporting the modules within the solar farm manually, it is difficult for such large panels to be transported manually for fitment. And you could see quite a challenge in terms of damages and all. With India not having robotic vacuum logistic handlers, how do you foresee as the size increases to 630 watts and all, and the size becomes 30% more, 40% more with much heavier panels? How do you see the future in terms of the installations? Because you are going to be a player in large-scale solar farms.
Yeah, no, I think Sunilji, very relevant question, and I think somebody else also has touched upon during this conversation. So it's not related to wattage, but yes, it is related to the combination of wattage and efficiency, which ultimately boils down to the size of the module. And the size of the module has already increased to the extent that it requires at least 2 or 3 people handling one module which itself is logistically a bit of a challenge. So I don't think the size of a module can further increase as far as Indian logistic environment is concerned. Going forward, it has to be more of an efficiency improvement rather than a size increase in the modules.
Sanjeev, do you see these 600 watt modules bringing a revolution in the Indian residential rooftop market, especially the small roofs? Because the total demand, if you look at demographics of Indian people and the size of the roof, probably 1.2 kilowatt or 1.5 kilowatt is what is the demand in smaller households.
Yeah, so it obviously is beneficial that you have lesser number of modules to handle. So instead of 3 modules, you're handling 2 modules like a 1.2 kilowatt. But I will go back to Parag's point, and that's the point probably I didn't emphasize earlier enough, is about the size versus the efficiency. My assumption here is that in the same size, you're giving us more wattage. Only then it makes sense. Because if you're just increasing the size, it's creating more and more complexity in terms of how we actually install it and implement it. So by small reduction, the balance of system is not going to be much helpful. One can have these 2 panels versus 3 panels, but I don't think it's like really going to make or break the equation in terms of how people will perceive solar. And I think if you have space for 2, you can have 3. I'm assuming that this is not such a big deal.
So would Koo like to respond to 2 of them saying that the need of the hour is improving the efficiency, not the size and the wattage?
Yeah, so from a Trina perspective, I think for the module efficiency, what Trina has done is that particularly for the latest Vertex module, what we have done is that we have incorporated many innovations based on our 200 mm silicon wafers with high densities encapsulations and a multi-busbar technology that we have introduced. So for the latest 540 and 600 watt module, what we have done is that we actually have done some of the so-called the gaps between the cell to cell. That's going to be a very, very narrow gap, so like less than 0.5 mm in terms of the gap, so that will definitely improve the entire module efficiency for the same so-called the form factor that's available out there in the market, which is, we call it the industrial standards right now. For installers like going to Amplus or maybe even to some of the developers out there in the industry. So from a Trina standpoint, the putting more innovations in terms of and technology to improve the module efficiency, that will be key to us. So that's the efforts that Trina will be continue putting a lot more efforts, from R&D efforts, as well as to improve. I think Mr. Sharma was talking about in terms of the logistics of the handling the bigger modules as well. From Trina perspective, all the module that Trina is shipping to the markets right now, and it comes with the frame, be it the double glass, be it the bifacial module, or of course the standard backsheet module will continue to come with a frame. So with frames on the double glass module and then bifacial module, I think that would definitely be able to improve in terms of ease of handling, as well as in terms of logistics and transportations along the way.
So good, thank you. I have a question. I would probably now move on to the questions from the audience which we are getting. And Mr. Koo, can you answer? This is a very interesting question. Which solar module technology is more competitive? Bifacial, heterojunction, hybrid, conventional, monosilicon? He's named all of them. So he's asking which is more competitive.
Well,
Mr. Goutam, you would like to take?
Yeah, I can answer.
Yeah.
See, any technology, because if you look at the Park technology, it was invented 1988. I mean, it's more than 30 years. Right? So any technology, there is a maturity, number one, and next thing is the mass productions. And you have to see the acceptance to the to the market. Right? So today, the Park technology with the PTI, which is 21%, but we have not discussed about the N-type material. Right? Now, why is the N-type material is so good, for future, because if you look at the device level, I mean, the electron in the hole, the photon is nothing, electron hole. The electron mobility is at least 3 times faster than the hole. So therefore, in N-type, the current density is much, much high. So there is an improvement in efficiency to 22 to 23% in the N-type material. It's not only that, we have to look into the degradations level, not only in the first year, in the subsequent year as well, if you look at the basic material earlier, boron dope material was the p-type, and N-type is your phosphorus dope, So nowadays the gallium doped has also come, in a sense, like how you now improved on your LID as well, So on the technology front, the heterojunction is there, but yes, it will come, but until now is the mass production. But heterojunctions is more efficient with the N-type materials, right?
But which is most competitive? He is wanting to know which is the most competitive in terms of pricing, obviously.
Pricing obviously is a bifacial as on date, because as a developers we buy the module as a monofacial, but with the engineering we are taking out the bifacial, right? So that's a very simple answer. We are taking the albedo. I mean, so because of the, but there is a little bit I can discuss as well. There is an additional cost, and with the fixed tilt versus with the tracker. But with the tracker, we have seen is the bifacials is much efficient, and with the conventional the graphs. But only thing is that to get an albedo, you have to improve to your the structure's height. That's on 1 meter minimum. So there are different area in the different reasons, and we can get the more generations, the rear side generations rather than back generations, and we can improve our generations efficiency with the bifacial module as on date.
Okay, thank you. So, Parag, I have a question from our audience that will the solar ROIs come under pressure with the end of benefits like ISTS waiver, slowing demand, need to firm up profile using storage? Discoms have got used to a sub rupees 2.6 tariff. This is question.
No, definitely it will come under pressure, and better than anyone else. But the good thing is that maybe the transmission charges are around 1.5 rupees. And even if we add, let's say, the 235, 240 tariffs, this 1.5 rupees, we are still not very far off from most of the coal-based power plant variable cost of energy. So we are already there, and by the time we have a window of time till March 2022 end. So by the time maybe the solar is more closer to 2 rupees. So even if there is a loading of transmission charges, we are very well within 3.25, 3.5 number. And as the new trend is that have more loading on the transmission line, which means that along with the solar, you are doing wind, or you are also doing storage, which means lesser loading on transmission charges ultimately. So if we are able to make this transmission charges per unit less than 1 rupee and the solar tariff is 2 rupees, then in the long run, whenever this waiver will go off, we can very competitively stand against coal-based power plant or any other technology. 3 rupees obviously is a very competitive tariff.
Good, thank you. So there's another question that which I would put it to Sanjeev. Because Sanjeev, you do ground mounted also and rooftop also. How do you foresee requirements of robots for dry and wet cleaning of solar panels in large solar farms as well as in rooftops, which will unlock better value?
Yeah, so in the rooftop, we have been completely unsuccessful in using any robotic cleaning just because of the profile of the things. We have tried unsuccessfully various times that how can we have a robotic cleaner which can move from one row to another without having people moving it, because then the whole purpose is lost. But I think on ground, definitely there is a scope, though I'm not sure how successful it is, though in some of the areas people are using it. So it depends on the type of the dust that is in the area. So I believe in the where there is more like dry dust, probably it is much more beneficial as compared to some of the sticky dust, which may be more in the northern side of the country, particularly in the winter months. So how a robotic dry cleaning is really going to work, though we all know what is the issue with the water availability. So I think we have to use these robotic cleaners, but it will be more case to case. It can't be just we start using it everywhere.
Brenda, would you like to throw some light, because your Brookfield has an international exposure. You got large assets under your belt. So what is your view on how do you see the requirement of robots moving forward?
Yeah, sure. I think Sanjeev said it well. Like it's not just buy and deploy it. We have to actually study the conditions and the type of settlement on the panels, right? That is it a pure dust particle alone, or there are too many birds moving above? The bird droppings would be there. So it's kind of slight analysis about the quality and the quantity of the dust there. Again, optimizing within the plant itself, the peripheral rows might have more, the internal rows might have less. So there are systems like dust monitoring systems and all, where if people can actually understand in that particular area how it is, that would certainly help. And certainly for the large plants like 300, 400 megawatt plants, it's going to be handy. And wherever we have been able to implement this, it's been successful. And going forward, the most of the projects which are lined up in Rajasthan, we were very certain that amount of water we're never going to get. Almost all the new projects which anyone is building there in that area, they're planning along with the robotic cleaning, waterless cleaning. But at times we might have to kind of blend the manual cleaning cycles as well, just in case if there are the bird droppings and few other dust which are not cleaned properly. With the robotic cleaning, it's not all the time you clean it full, right? The dust settles down on the bottom or on the sides where the frames are there. So that also stays for a long, and there are rains. There's a possibility it gets causes corrosion on the areas, on the edges and all. So it's a mix of both. So we typically we kind of do at least once in a quarter outlet cleaning as well, in addition to the robotic cleaning. That was actually fitting the purpose, and we've been successful last 2-3 years in a few of the projects. So that's been working well. So at times we may have to do the wet cleaning as well.
One last question from my side, not from the audience side. In next 5 years or next decade, what is the trend for the solar module technology you think will emerge? Will monopoly remain a mainstay, or you will see dramatic changes in the module technologies in the next decade? And whether you'll go in for N-type and multiple heterojunctions or whatever it is.
Very good questions. So I mean, this is continuously going to be, for module manufacturers like us to explore what is going to be, and the key that for us is going to be what is going to be really so-called economical, and provide the standardizations and compatibility to the industry. All right. So I think early on, you mentioned about what's going to happen on comparing the previous 1,000-volt system to 1,500-volt systems. So this is one. And at the same time, I think the panelists also talk about the size of the modules. And these are continuously going to be considered into our R&D effort in terms of putting that so-called innovations into the panels. So coming back to answer your question is that, today we have the P-types, right? Then we have innovations or going to the bifacial module with other system integrations, like, putting a tracker to improve the entire system's efficiency in terms of U generation to bring down entire LCOE. All right. So in other technologies that are available right now in the market, like, the heterojunctions, maybe, we even have explored the option having so-called a back contact cell, which having a much higher in terms of cell efficiency to improve the entire module efficiency as well. However, all these high technologies out there in the market, for instance, the back contact cell, they are not economically put into food production that we can sell it economically. That all the industries players like and developers like yourself will consider that into a very low tariff markets, like for instance for India and elsewhere out there in the markets. So when we as a module manufacturer, when we introduce products into the industry, we have to find a balance of the technology as well as economical, whether this is going to be affordable to the industry. Most recently, yesterday, Trina has launched globally for one of the so-called 60 cell configurations for a rooftop market. That's we have two versions. One is based on the all black module, which is very much for aesthetic purposes. There's a 405 watt module, and that's very much dedicated for a rooftop market, which is for residential. So we will continue going to be putting a lot more innovations and the form factor, which are going to be suitable for the industry at the same time, economical, where everyone's able to be affordable for the installations. I think that's going to be key.
Well, thank you so much. As a last word, I believe that it's not only the technology innovation in the modules and inverters which is going to take place, but I believe my co-panelists will agree that how you are going to schedule and forecast your power more efficiently to take that last drop out using algorithms which are going to be far more advanced. You're going to use blockchains for selling power like Sanjeev and all do in T&I segments. And using hybrid technology to extract the last thing from the evacuation infrastructure. I believe there are use of technology, whether it is drones for O&M purposes, so that at the right time. There are many technologies happening which will bring down the LCOE as well as make your life far more easier. On that note, I thank all of you for such engrossing discussion, and thank all the audience for being patient with us and listening to us. I know we don't have so much of time for many questions, but there have been a lot of questions being asked with us, but probably we can take them offline as we run out of time. But let's believe in technology and Internet of Things to move forward to bring down the cost of solar energy. Thank you so much.
Thank you.
Thank you. Thank you.
Thank you
very much.